Hello everyone. Today I am going to discuss about the concept controllability and observability. So for this I have taken a question. So we determine the state controllability and observability of the system where the matrix A is given by this, B is given by this and C is given by 1, 0 and 1, which is a row matrix. So now first, for checking the state controllability and for checking the state observability, what are the things we have to find was we have to find the controllable matrix QC and the observable matrix Q0. If the controllable matrix QC and Q0, if they are going to be the determinant, when you find this QC and Q0, if QC and Q0, the rank of this or the determinant of this matrices, if it is not equal to 0, that if both the elements are going to be having the finite value, then we can say that the system is controllable and system is observable. So now for this given problem, we are going to check whether the system is controllable and observable. So now for this, first we are going to talk about the controllability of the matrix. So now for checking the controllability of the matrix, the first what we are going to formulate was we are going to formulate the controllable matrix, and the controllable matrix is going to be given by, depending upon how many columns we are going to have here, we are going to formulate the QC matrices. The QC matrices is going to be given by B, AB, A square B, A cube B, and so on, A to the power of n minus 1B. So now coming to where we have to stop this, so depending upon how many number of columns we have here, we are going to take that many number of columns from this QC. Now for our given problem, the QC is going to be having B, AB and A square B. So now we are going to use these matrices and we are going to formulate these elements. So now the first thing, B. So B already in the given problem they have given us 0, 0, 1. So next we have to formulate AB. So and A is going to be given by minus 1, 1, 0, 0, minus 3, 2, 0, 0, minus 8 into B. B is going to be given by 0, 0 and 1. So now we have to write the multiplication of these two matrices. If we write the multiplication of these two matrices, so we can go with minus 1 into 0, 0, plus 1 into 0, 0, plus 0 into minus 8, 0. Next coming to this 0 into 0, 0, plus minus 3 into 0, 0, 2 into 1, plus 2. And coming to this row, 0 into 0, 0, plus 0 into 0, 0, minus 8 into 1, minus 8. So now coming to the second element AB, it is going to be given by the column 0, 2, minus 8. And next coming to the next column, which is given by A square B. So coming to this, we have to find first A square and then we have to get multiplied that A square with the B. So for that we are going to take minus 1, 1, 0, 0, minus 3, 2, 0, 0, minus 8 into minus 1, 1, 0, 0, minus 3, 2, 0, 0, minus 8 into the B matrices was given by 0, 0, 1. So now first if you multiply these two matrices, we are going to get 1, minus 4, 2, 0, 9, minus 22, 0, 0 and 64. This was A square element. So now this is going to be gets multiplied with 0, 0, 1. So if you do this, we are going to get a column 2, minus 22 and 64. This was the column matrix for the element A square B. So now what we have to do was we have to formulate the matrices QC with this. So now for formulating the QC, so we are going to write QC is equal to, the first column was B. So B is given by 0, 0, 1. And now coming to the second AB, it is going to be given by 0, 2, minus 8. And coming to the third, it is going to be given by 2, minus 22 and 64. So this is the third column what we are going to have. So now we need to find the determinant of this QC. So and if you find the determinant of this QC, it is going to be given by minus 4, which is not equal to 0. So the system is said to be controllable one. So if you, what we have considered, if you find the QC and after finding the QC determinant, so that is determinant of QC and Q naught. So when determinant of QC is not equal to 0, system is controllable. So if the Q naught is not equal to 0, system is observable. So now according to the thing what is happened here, so our QC determinant was equal to minus 4. So when we find the determinant of QC, so it is going to be given by minus 4 and which is not equal to 0. So the system was controllable. So now in the similar manner what we have done here, we will go with the controllability of, we need to check the observability of the same system. So now for finding the observability of the same system, I am going to consider the observability matrix Q naught. So coming to the observability matrix Q naught, same as the case of the same as the case of the QC, here also we are going to have one matrices format which is given by C transpose, A transpose C transpose, A transpose whole square C transpose, A transpose whole cube C transpose, and so on, A transpose whole to the power of n minus 1 C transpose. So this is the actual formula for the writing of the observability matrix. So now coming here, so we need to go with the check of the matrices A, which is going to be having, so 3 columns. So we are going to represent only the 3 columns for Q naught, which is C transpose, A transpose C transpose, A transpose whole square C transpose. So now we need to write what are the elements C transpose, what is A transpose, what is A transpose C transpose, A transpose whole square. We need to write all the terms. So before that, first we are going to write what is the matrices A here. So A is going to be given by minus 1, 1, 0, 0, minus 3, 2, 0, 0, minus 8. And if you make it a transpose, then A transpose is going to be given by minus 1, 0, 0, 1, minus 3, 0, 0, 2, minus 8. So this is our A transpose element. So now coming to the matrices C. So C is going to be given by a row matrix 1, 0, 1. So now if you make it C transpose, it will be 1, 0, 1. It becomes a column matrix. So the elements now what we have to use was the A transpose and the C transpose. So now first coming to the first element C transpose, it is going to be given by already here 1, 0, 1. So next we have to go with A transpose C transpose. So A transpose C transpose is given by A transpose is minus 1, 0, 0, 1, minus 3, 0, 0, 2, minus 8 into the C transpose was 1, 0, 1. So if you go with this, so we are going to have a matrices of minus 1, 1 and minus 8. This will be the A transpose C transpose. So next we have to go with A transpose whole square C transpose. So now if you go with this, A transpose whole square was already we are going to have A transpose here. So we are going to write here as minus 1 0 0 1 minus 3 0 0 2 minus 8 into minus 1 0 0 1 minus 3 0 0 2 minus 8 into C transpose 1 0 1. So now when we multiply these two elements, so then we are going to get 1 0 0 minus 4 9 0 2 minus 22 64 into we are going to have here C transpose 1 0 1. So now if you multiply these elements with this, so then we are going to have a column matrix of 1 minus 4, and lastly the element what we are going to get was 66. 66. So now when we want to represent the matrices Q naught, so Q naught is actually given by the first column C transpose is given by 1 0 1, and the second column which is given by minus 1 1 minus 8, and next the third column A transpose whole square C transpose which is given by 1 minus 4 66. So now if you find the determinant for this Q naught, it is going to be given by 37, which is also not equal to 0. So the given system is also observable. So for the given problem, the system becomes both controllable as well as observable. Thank you.